I think the best way to go about this chapter is to split it up into quadratics and cubics, because if you take a look at your textbook, it's only quadratics and cubics that we're going over and a bit of linear. But I already discussed the bulk of all your linear stuff in part 1. So let's hop right into quadratics. So a quadratic is as we discussed in the previous lesson, quadratic is a degree 2 polynomial. Quadratic is a degree 2 polynomial, which in standard form is written in the form ax squared plus bx plus c. So you can write p of x equals ax squared plus bx plus c. This is the standard form of a quadratic. So we can graph quadratics, and that's what NCERT chooses to focus on. The graph of a quadratic is a parabola. Parabola is the graph of a quadratic. You'll notice that the best way to graph a parabola is actually using vertex form. We're going to do a little bit of sidetracking here, but I don't think this is not important for the unit, but vertex form is in the form y equals, so you can skip this part if you want. Just fast forward a bit. But once I start talking about the actual, and I start drawing out the graph of a parabola, then you need to focus. That's in NCERT. That's in your textbook. So if I do y equals a times x minus h squared, we may or may not learn this in the future, but where the actual vertex, or I forgot to add plus k, with vertex of h k, this is vertex form of a parabola. So a parabola has a vertex, and now you should start listening in. So the graph of parabola looks kind of like this. Goes up in both directions. The vertex is at this point. Right, and the graph is symmetrical about the vertex. So if I draw a vertical line down through the vertex, and usually it's parallel to the y-axis, the line that goes through this point right here is the vertex, which is in vertex form. So it's kind of like a sidetrack thing, like you don't really need to focus on this. So that's the graph of parabola. Now, there are multiple cases for these graphs. First case is, which is the most common case, is the parabola intersects the y-axis in 2 points, which means this quadratic has 2 real zeros. 2 real zeros, and each one of these points is a 0, as we discussed in part 1, because the amount of intersections with the x-axis is the amount of zeros, and each one of these points represents a 0. Case number 2 is if you have a tangent parabola. Tangent to the x-axis. This means you have 1 real 0 at that point. This also happens to be, most of the time, the vertex. One real 0, and then you have no real solutions at all, which, you guessed it, if it doesn't intersect with the x-axis at all. That's no real zeros. So this is 1, 2, and then no real zeros. That's the graph you need to focus on for the number of solutions or zeros. The other thing you need to focus on is which way does the parabola open up into. We can go into many different details of like does it open like in more advanced classes. You might see like if it does open like this, or does it open like this, right? We can go into all of that, but what you really need to focus on is the a value. So a value is, in the standard form, the coefficient of the x squared term of a quadratic. When I graph this, if a is negative, then the graph of this will open up downwards. So this is if a is less than 0. But if a is greater than 0, then it will open upwards. That's if a is greater than 0. And that's all you need to know about the graph of a quadratic polynomial. Other thing we need to focus on is the sum and product of the roots of a quadratic polynomial. So the main thing you need to know is if you have a quadratic polynomial p of x in the form ax squared plus bx plus c, okay, then the sum of the zeros of this, okay, if the sum of the zeros of this quadratic is going to be negative b over a, always, and then the product of zeros is going to be c over a, always. So now let's scroll down and see some practice problems. So there's two types of problems you're going to get. One is just finding the sum and product of the zeros of a given quadratic polynomial. This is kind of easy because you already know the formula. So example, I want you guys to find the sum and product of this polynomial, of the roots of this polynomial. There's zeros, my bad. You should know that some textbooks, if you study out of other textbooks, might call it roots instead of zeros. Plus 8x plus 10. Find the sum and the product. Alright, pause the video, figure it out, because I'm going over the solution right now. Sum is negative b over a. That's negative 8 over 5, because this is a, this is b, and this is c, which is just negative 8 over 5. Can't simplify that any further. The product of the roots is c over a, which is 10 over 5, which is 2. That's the sum and the product. Done. Another problem you might find is if they give you a polynomial, and then or they give you the sum and the product of the roots of the polynomial, and then they want you to find the quadratic, find just one quadratic that has like the sum and the roots to be those sum and root, like that sum of the roots and that product of the roots. So for example, I know NCERT gave you like find a quadratic polynomial with the zeros, like, and they gave you 2 zeros. You can check in your textbook, but they didn't really explain how they got the answer. I'm going to go ahead and do that right now. So what they did was, I think they gave you like x squared plus 3x plus 2 was like the answer. They said the sum and product of the roots, they gave you some, like the sum and the product of the roots. If you go back and see, you can apply that and actually figure out how they got the answer, we can just use our example right here. So if you don't know the quadratic, you just knew the sum and the product of the roots of a quadratic, how can you figure out the original quadratic? Okay, so pause the video, figure it out yourself. And if you don't understand, I'm going over right now. The sum of the zeros of a quadratic is negative b over a. And we're given that we have negative 8 over 5. We don't know the quadratic. We don't know that this thing even exists yet. Or we don't know it's related to this problem. Imagine we just know the sum and the product of the zeros. Then we know that negative b over a, we can just write out this as ax squared plus bx plus c. And negative b over a is negative 8 over 5. And then the product of the roots is 2, which is c over a is 2. Now, if you see a in both of these equations, it's wise to solve each one for the variable that's not a. So in this case, let's solve for c. C is then 2a, right? Because I multiply this up here, multiply both sides by a, it's canceled right here, then we have 2a. C equals 2a. Over here, we can cross multiply, so negative 5, negative 5 times negative b, let's do negative 5b equals negative 8a. And then we can multiply by negative 1, get 5b equals 8a. b equals 8a over 5. We have b and c, so we can substitute them back into the original equation, which is ax squared plus b bx 8ax over 5 plus c is 2a. Now, this is the general form of any of these polynomials, right? Any quadratic polynomial that has the sum and the product of its zeros to be negative 8/5 and 2 respectively is going to be in this form for any value of a. So to figure this out, we can just plug in any value of a. Now, since you want all of these to be integers and nice, we can just do a equals 5. Why? Because if I put a equals 5, then this just cancels out this fraction right here, this denominator. So a equals 5 gives us 5x squared. Over here we have 8ax. 8 times a times x over 5. A is 5. These cancel out, so you just have 8x plus 8x. And then plus 2 times a, 2 times 5 is 10. And go back up. That's the original one we had. There's obviously more, so you can write in general if it ever asks you to do this, which I don't think it will. Okay, if it asks you to do in general, you can just write in this form. So you can factor out the a, and you can write the general form is a times x squared plus 8/5 x plus 2. That's a general form for any one of these polynomials in this form. And that's how you do these types of problems in your textbook. I'm going to post some practice problems in the description. Be sure you're solving those. Posting solution videos of those soon, so be sure to stay tuned for those.